My name is Aaron Kolb. I'm an instructor here at Harper College in the Advanced Manufacturing program. I was in manufacturing for about 32 years before I came to Harper. I've been at Harper 9 years now. We've got all kinds of classes from manual machining to CNC to blueprint reading and quality. And we've got 11 CNC machines now. We've got everything from 3-axis mills to 2-axis lathes. We have a 5-axis machine. We've got 4th-axis rotaries, and now we also just added a Y-axis lathe with live tooling and the subspindle. The manufacturing and welding program that we have here at Harper, there's a lot of opportunities for scholarships. So if it's something that you think you'd like to do but always thought you might not be able to afford, there's always money left on the table at the end of every semester. So there's all kinds of scholarships that you may or may not qualify for, but that's also something that we could look into if this is a program you're interested in. Manufacturing is in all different kinds of industries, and whether you choose machining or CNC programming or welding, there's always an opportunity for you. And this type of education not only puts you in a position to work on the shop floor, it's also a great stepping stone if you've ever thought about going into engineering. It's also a really good starting point for industrial sales or machine installation or repair. There's a lot of different jobs that are available in manufacturing, and whatever you like to do, there's probably a place for you in manufacturing. And again, whether it's welding, advanced machining or programming or fabrication, there's all kinds of opportunities. The last thing I'll say is there's all the concern about AI taking jobs. This is one industry where most of our jobs are safe from AI technology. And in fact, we welcome AI in CNC programming and setup and automation because it's just another tool, and it's going to help us be more efficient and help us do our jobs better and be more productive, but it's not going to take our jobs. Actually, it's going to create more high-tech, high-paying jobs than what we have right now. If you've ever thought about exploring a career in manufacturing, come out and check out our program. You can go to the Harper College website at harpercollege.edu. Under there, you can find the tab for manufacturing. You can find any of the instructors under there as well, and you can email us with questions. You can also call or email registration or our division office and career programs to answer any questions that you might have about our program. All right, so we're going to turn the first stop of this shaft. We're using a Vargus grooving tool, which is radiused on the end. It looks like a dog bone insert. We're going to be running this at 1800 RPM, and we're going to be at a feed rate of 8 thousandths per revolution. And so it's a pretty aggressive cut for a groove tool, but you can see that there's no chatter. The chips are coming off nice. We're roughing this in 2 passes, and then we're going to do 1 finish cut. And so what this operation is doing is it's cutting the taper for the NPT thread, and then it's also cutting the diameter for the first part of the shaft. All right, so we've got the tools touched off again. We're just going to rerun the part. It's a couple thousandths oversized, so we're going to rerun this. We'll run it without coolant, so you can see that at least the tool path. It won't be doing any cutting until just a skim cut on the last pass. All right, so we're just going to touch this tool off the Z-axis. The X should be set from the first time we ran this part. And then we are going to thread the NPT thread on the end of the shaft. Okay, so this project we're using a Haas TL1 lathe, and the way these are configured, it's a tool room lathe. And so we're actually doing each operation of this shaft separately. These are not a production machine. And so in the first operation, our first setup, what we did is we turned the OD of the first part of the shaft, and then we turned also the thread diameter of the NPT thread that we're gonna do now in this operation. So this is another Vargus threading tool. It happens pretty fast. And we're all set up and ready to go. And that's that operation. You can see we've got some nice threads here on the end of the part. And we're gonna break this down and we're gonna get ready for the next operation. We're gonna flip the shaft around. We're gonna turn the other end. So this is our third operation, our third step in this process. And what we did is we turned the shaft around. And now what we call the long side. So this is the side. We're gonna turn the OD and then get it ready for putting some OD grooves into it. And then our last operation, we're going to drill and bore this final end that we're turning now. And so again, we're turning it at an RPM of 1800, which is the max for this machine. And we're turning it at a feed rate of 8 thousandths per revolution. I believe the depth of cut is about 40 thousandths per side. And again, this is a groove tool with a dog bone shaped insert. And we're going to take 2 roughing passes and then a finish pass. So we're getting a little bit of chatter at that tailstock end. Again, I think it's due to the small diameter of the part and how far we're sticking out, even though it is supported by that tailstock. Again, this is a TL1. It's a tool room lathe. It's not the most rigid machine. And we'd probably get a little different result if we were using slant bed turning center. And so for this last finish pass, we're going to turn this at a 5 thousandths feed rate. All right, so this next operation, we're going to put a series of OD grooves into this shaft.
Groove finishing here. Delete. Let's edit. Groove. And just make sure we go through. Collision check is off. Ramp, arc angle. Just do this as 0. 20,000 tangentials. And all right. Every path, as you see, is coming down. Here, let me turn this off. It's coming down, going across a little bit,
Gotcha.
and you have another one going across. There's like a 2,000 overlap when it can, but each side walks down the wall,
Okay.
You know, same thing. This one's going to plunge because it's actually the groove plunging, but then it's going to come down, you know, it's going to come down, wipe through, you know, has a 2,000 overlap, go through. So that's what it's doing.
Cool.
All right, so right now it's making a series of small grooves. It's kind of roughing out, which is going to be the area of a larger groove, and then it's going to come back and finish that space. So after it roughs these grooves out, it's going to go make some individual grooves down at the other end of the shaft, and then it's going to come back and clear that larger space out. And here we are finishing that larger groove. So we're running this at 1800 RPM, and we're using a feed rate of a thousandth and a half per revolution. All right, so next we're going to set this up, and we're going to bore and thread the end of this part. And so what we're doing is we're going to chuck up on the very end of this part for rigidity. And we're going to drill this out by hand. And then we're going to come back in with a micro boring bar by Vargus, and we are going to put in a counter bore into the end of this shaft. And for this, because we're doing this by hand, we can actually keep the door open. And again, nothing too special here. It's the same operation that we would do if we had a manual lathe. And so we're just using the tailstock to drill a hole on the center line of the part. And I'm retracting the drill every so often just to clear the chips from the drill and from the hole. Okay, so we've got the hole drilled. We'll set this up. We'll bore this to the correct diameter, and then we'll thread it, and then we'll be done with this part. So what I'm doing is I'm taking a small cut in the bore. I leave the tool at that diameter. We're going to measure what that bore is, and then we're going to tell the machine where that tool's at as a reference point. And so now when I program a diameter, that tool will know exactly what diameter to go to. Okay, so now that we've got that reference, we can call up the correct program and we can bore this out.
Okay, I have the ID boring inside of here already, so let's just make sure that it's doing what I want. All right, that looks fine. It's feeding in, and then it's actually cutting material. I can do something like this where I can pull it out.
Yeah, because that was kind of my concern, that we would push a big burr on that last pass up here.
Yep.
So I was
All right, we should be ready to go. And we're going to attempt to run this without coolant. We may find that we have to add a little bit to clear some of the chips, but we'll see if we can get by without coolant to give the best view of this operation. So right now it's boring out the counter bore, and we're at a speed of 1800 RPM, and we're at a feed rate of 2 thousandths per revolution. And then on the last pass, it's going to take a skim cut on the bore where we're going to put threads. And so now it's going in for a finish cut. And I'll finish the counter bore, and then it will continue on to the thread bore. Okay, that operation's finished. We have one operation left. We're going to set this tool up to do some threading, and then this part will be complete. Okay, so I'm putting our threading, our micro threading bar, again by Vargus. And we're just going to touch this off quickly, like we did the other tool, to give it its reference point. And then we will thread this and be done with this part. And so the holder that we're using is typically seen on Swiss machines that we use for the bore on this op and the threads. Now, we didn't have a holder for this machine that would accept a round boring bar, and so we went with more of this kind of offset holder that, again, you see on Swiss machines. But it's working really well. Okay, so we've got our tool set. We'll call up the correct program, and then we will thread this part, and we will be done. And again, we'll try to do this operation dry. The threaded quality may not be the best, but it'll give you an opportunity to see the process maybe a little bit better.
So then I have the boring and the finishing. So we're going to rough this, and we're going to come in here, pick it, pull the material out, and then we'll come in with the threading tool. So thread MPT, perfect. Then we turn up to, and then we groove. We are grooving, grooving, drill, boring. But yeah, I'm in order. Numbers aren't quite in order, but process is in order, so that's what matters.
All right, ready to go. Again, you can see how fast this threading tool threads. And that's it. We have a complete part.
Hi, I'm Elizabeth with Bruker Alicona, and today we were able to measure the roughness on the flank of the thread on this part using our focus variation optical 3D metrology device. So we have our part on the table here. We're able to vary our device up and down in the Z direction, use our focus variation technology to capture a 3D data set of that thread, which you can see over here. So not only were we able to measure a roughness measurement on the shank of the tool, we took it back to the Alicona labs and measured across the entire 20 millimeters of the threads. We took a profile along those threads and grabbed all of those measurements. And then we also were able to take a roughness measurement along the flank of those threads. When we apply a 250 micron lambda C filter to that, we got an RA value along the flank of about 0.6 microns.